Let's take a look at how to graph a parabola in vertex form by hand. If you want to use your calculator to do this, you certainly could. I'm not going to show how to do that. I showed that in the standard form graphing parabola video, so if you want to do that, you can sort of repeat the same process here. But what's nice about vertex form, it's really easy to do by hand. It's really easy to find the vertex by hand and therefore find the max or min by hand. So your giveaway for something being in vertex form is you're going to most likely see you're going to see a parentheses squared, and there's usually going to be something added here at the end. So and if you've remembered from previous lessons about what A, H, and K do, they repeat and they do the same thing they're going to do with this parabola. So our H value will be our horizontal shift, but it lies to you. It does the opposite of what it says. The K value will be your vertical shift, and it does what it says. So here's our parabola in vertex form. To do this, I'm going to graph just one point and make a sketch. If you want to be more accurate, you could plot more points or look more points up in your table, but I'm just going to make a quick sketch using 1 point. So my vertex, because I'm in vertex form, is really easy to find. Just take the opposite of your H value, so -2, and take your K value just the way it is. So my vertex is going to be at -2, 5, which the 5 would represent either then the min or the max, depending on which way this parabola is opening, which is the next thing I'll figure out. I know that this parabola is opening downwards because my A value was negative. If A is negative, it's going to open downwards. If A is positive, it'll open upwards. So because this parabola does open downwards, I can see that it's going to have a maximum value, so 5 would be the maximum of this parabola. And finally, I'm going to just make a note about whether the parabola is wider, narrower, or the same width as the parent function. Again, I'm going to look at the A value to do that. If the A value is less than 1, that is going to make the parabola wider than the parent function. If the A value is bigger than 1, it'll make it narrower, and if the A value is 1, that's just the same width as it. So with that information, let me just go ahead and make a quick sketch of this parabola. So my vertex was at -2. And 5, so my vertex should be right about there. We know it opens downwards and it's wide, so I'm just going to kind of over-exaggerate the fact that it's a wide opening parabola. Again, it's just a sketch. It's a really bad sketch, but it has the basic information to it. If you want to be more accurate, then go ahead and plot some more points. But I suppose I'll go ahead and draw on the axis of symmetry as well. It's going to go right through the vertex. And remember, that's just going to be x equals and then the x value of your vertex. So x equals -2 will be my axis of symmetry. Let's go ahead and just try one more of those, and we'll do a story problem example after this. So again, I'm dealing with vertex form. My giveaway is that I've got parentheses squared, and then a number being added or subtracted at the end. So my vertex is really easy to find. Just take the opposite of your h value, which is right there, and then take the K value just the way it is. So 5, -1 is going to be my vertex. This parabola will open upwards because my A value was positive, and since the A value is bigger than 1, that's also going to make this narrower, so it'll be a skinny parabola. So let's take that information and make a quick sketch. So my vertex was at 5, -1, 1, 2, 3, 4, 5, and down 1. This parabola is opening upwards, and it is narrow, so again, just kind of over-exaggerate the fact that it's narrow to make a quick sketch of this. If you want to be more accurate, then go ahead and plot some points. I'm going to draw on my axis of symmetry as well, and I'll label that as x equals 5. And last up, let's deal with a story problem that involves a parabola that is in vertex form. Now, at first glance, these problems look really complicated, or fairly complicated. And as long as you understand how the vertex form works, they're actually some of the easiest story problems we'll ever take a look at. So, in this particular example, we're looking at a suspension cable on a bridge, and the suspension cable is hanging down in the path of a parabola, which is given to me by this equation right here, which is in vertex form. There's your parentheses squared. So the question that they've asked me is how far apart are the two towers, and then what's the minimum height of the suspension cable. Again, it may seem complicated, but watch how simple this problem can be. So the first thing that I'm going to do is I'm going to identify the vertex of my parabola. The vertex, because I'm in standard form, is just going to be 1400, the opposite of the h value, and then comma 27 as the y value. So there's my vertex. We'll take a look at what we have then. And if I were to walk from the first bridge all the way to the center where the vertex is going to be, that's going to be a distance of 1400 feet. And because I know the vertex is right there in the center of the parabola, and this is all symmetrical, if I were to walk the other half of the bridge, that's also going to be 1400 feet, which means the distance between the two towers is just 2800 feet. They also asked me what's the minimum height of the suspension cable. So in other words, if I were to walk to the bridge where I was closest to the suspension cable, that's going to again be right at the vertex. And I know the roadway and that low point of the vertex is 27 feet up because that's where my vertex is located. So the minimum height is just 27 feet. So again, very, very easy to do as long as you understand the form and how it works.